Okay, we're going to introduce a new system for measuring angles. So we know a circle has radius r. Okay, so let's draw that on. Might have some radius r then. Okay, if we can find a sector such that the length of this sector is equal to r2, or just r, yeah, but r as well is what I'm trying to say, not some sort of different length. So this is the same as the radius, then this angle theta is equal to 1 radian. Okay, so that's how we define the radian. You don't need to get too caught up on, what is a radian. I mean, because what's a degree? We're used to measuring in degrees. We define some basic definition of the radian, and it has some nice properties. There's a reason we define it like this, and we'll see a couple of formulae that can be useful now. So let's add another circle, one a little bit bigger, just so we can see this without getting on top of ourselves. If we have some radius r and another radius, pretend this is a straight line, so these are both r obviously, and this is a sector. Okay, so this angle's theta, and this is theta in radians. So for these formula, it's in radians. We have formula for arc length and area of a sector in degrees. These are the equivalent formula in radians. So when we're working in radians, this length from this point to this point is L, and L is equal to R times theta. Okay, so you can see there's a lot less complicated than the form in degrees. If we want to find this area, let's call this A. A is equal to 1/2 r squared theta, and again theta is in radians here. Okay, when you take these formula and you compare them to the formula for degrees, then we can give ourselves a formula for converting between degrees and radians. Okay, because whether we calculate this length in degrees or radians, then the length's still the same, so those two have to be equivalent. So r theta in radians is equal to the formula in degrees, and when we rearrange that, we can find that the angle in radians is equal, multiplied by 180 divided by pi, is equal to the angle in degrees. And using this formula, we can work out some of the significant angles we need. So pi/2 radians is equal to 90 degrees. For radians, we can write rads, by the way, afterwards, or radians, but often we would literally just write pi/2. So pi/4 rads is equal to 45 degrees, and of course pi rads is equal radians is 180. So you can see this is quite nice, and yeah, and we can. So you might have been thinking, if this is 1 radian here, I mean, we're going to have, for theta just less than that, we're going to have 0 point on and on and on and on and on. But these key angles can often be expressed in terms of multiples of pi, which is quite nice. Okay, for now that's all we're going to look at. We're going to start looking at trigonometry in radians in the future videos. if you do have any questions about this, because it is a new topic, I think it's quite a simple one once you get your head around it, but it can be a little bit weird, like always when you haven't seen something before. So yeah, if you do have any questions, I'll try to clarify something down in the comments. Yeah, I'd encourage you to practice some questions of converting between degrees and radians and finding arc lengths and sector areas. If you did enjoy this video, please be sure to like and subscribe, and I hope to see you in the next one.